Like any star, it will run out of fuel in its core, and it starts changing. It starts bloating and getting so large that it will engulf the orbit of Mercury and Venus and come very close to Earth. So imagine looking on the horizon and sunrise is half the sky.
NASA has made footage of a previously unrecorded occurrence available, in which the asteroid nicknamed Betelgeuse burst overhead, destroying a significant chunk of its surface. The space agency claims that the event, called a supermassive ejection, SNE, is 400 billion times larger than a typical solar system. This occurrence is known to scientists as the observation period of stellar evolution. Many are perplexed as to how a star could leave such an item. This red supergiant's catastrophic explosion completely upended our conception of the cosmos. How come Betelgeuse blew up? What impact will this have on the cosmos? Numerous stars are positioned in the constellation in accordance with fables and traditions. Even now, they are still employed for navigating. One of the largest and brightest stars of the night is Betelgeuse. Winter Orion's guardian is a brilliant purple star known as Betelgeuse in the top right corner. Astronomers discovered, however, that it was a ghost with a heartbeat that could beat non-stop for up to 400 days after closer inspection. Betelgeuse is easily recognized by its vivid yellow-red hue. Suspicion that stars are colored differently is a good one. This star, sometimes referred to as Alpha Orionis, is the second brightest in the constellation, trailing only the blue supergiant Rigel. Owing to its adaptability and peculiar moniker, Betelgeuse is an intriguing subject for investigation and scrutiny. Within its constellation, the star, often referred to as Alpha, is the brightest. Because of its brightness, size, and red color, Betelgeuse is known as Alpha Orion, even though Rigel, Orion's brightest star, is brighter. He's also among the most well-known celebrities. Not to mention, the actor served as a model for the film's characters in Beetlejuice. Visible from much of North America and Canada, Betelgeuse is the 7th brightest and 10th brightest star in the sky. The world and Betelgeuse are not too far apart. The star nearest to Earth and brightest in our galaxy is called Betelgeuse. There are just 200 red supergiants known to exist. The Sun's radius is around 764 times greater than Betelgeuse's. This star will go beyond the asteroid belt and even Jupiter if it were to take the place of the Sun in our solar system. This implies that Mercury, Venus, Mars, and Earth will all be fully absorbed. 16 times bigger than the Sun is Betelgeuse. Located 548 light-years distant, this supergiant star has a solar luminosity of 126,000. The star is cooler than the Sun with a temperature of 3600 Kelvin. Visible light makes up just 133% of Betelgeuse's total emitted energy. Sirius would not be the brightest star in our night sky if Betelgeuse could see all wavelengths of light. Every 10,000 years, Betelgeuse smashes into a sizable solar system. Nebulae around red stars because they are dispensed unevenly from the star in all directions. The distance between the Sun and Neptune, the farthest planet in the solar system, is represented by the cloud of objects around Betelgeuse, which is 250 times bigger than stars. Solar flares are the periodic propulsion of materials into space by our solar system. But since the Sun only releases a tiny amount of its outer atmosphere, this phenomenon is known as a coronal mass ejection. As a result, surface mass ejections and coronal mass ejections will happen at various periods. Coronal mass ejections are produced when a star releases a portion of its unstable atmosphere. Coronal mass ejections from the solar system are common and have the potential to impact Earth and its people. At velocities exceeding 1,800 meters per second, coronal mass ejections propel magnetic fields and plasma into space, occasionally arriving at Earth in less than an hour. Large coronal ejections that happen on the side of the Sun that faces Earth can harm and occasionally even put humans in danger by impacting and damaging Earth's electrical networks and satellites. The precise reason why Betelgeuse closed its doors in 2019 is revealed by recent discoveries. The renowned constant appeal of Betelgeuse has likewise shifted. NASA's news release claims that Betelgeuse's coronal mass ejection is exceptional since it caused the star to tremble like a sheet of jelly by releasing 400 billion times the magnitude of a normal coronal mass ejection. Astronomer Andrea Jury of the Center for Astrophysics explained that while the photosphere, or what we think of as the star's surface, attempts to reconstruct it directly, the convection cell of the star may encounter an issue. For the last 200 years, astronomers have been regularly monitoring the form of the star, but it is no longer present. The ability to see the death process of red massive stars like Betelgeuse will help scientists understand more about the development of stars. The nuclear fusion that powers the majority of Earth's stars eventually fizzles out, leading the star to go through an unusual sequence of stellar alterations before dying. When a star is born, it is made of hydrogen, which combines at the star's core due to gravity to form helium in a nuclear explosion. During the fusion process, the majority of the heat and light energy is typically emitted. When this energy reaches the star's surface, photons are discharged into space. Helium starts to react with carbon to generate carbon as the star ages and its primary fuel, hydrogen, runs out. Neon ultimately reacts with carbon to generate a metal when helium is utilized. Nothing can withstand the gravitational pull of the star when this occurs. Therefore, the combination of neon and iron absorbs more energy than it releases. A supernova explosion results from the star collapsing in on itself when the iron starts to melt. The most potent natural objects are supernovae, which may create more than 10 billion suns. Depending on what stage of stellar development a star is at, its color can shift from the youngest, hottest blue to the oldest, colder red. Although Betelgeuse was given its unusual red moniker by the Greek scientist Timaeus, 345 BC, 250 BC, 3 centuries earlier Chinese astronomers had identified Betelgeuse as yellow, suggesting that Betelgeuse was formerly a yellow supergiant star. Bigger stars often burn up their hydrogen faster and eventually die. Even though Betelgeuse is just 10 million years old, his time is running out. Even at 5 billion years old, our Sun is still at its brightest. And since Betelgeuse is running out of time, there will shortly be a supernova. Betelgeuse experiences 2 cycles of light and dark. The second cycle lasts around 100 days and happens roughly every 5 years. During this cycle, it is anticipated that the star's outer shell will expand and shrink, altering the star's orbit and average temperature at each stage. Understanding how red stars shrink in their last stages before exploding into spectacular supernovae will become clearer to astronomers. Regarding Betelgeuse's explosion, Dupree wrote, "We didn't know what was going to happen since we've never seen a big volume of material escape from a star before. We are able to see this novel event with the use of. With Hubble, we can directly resolve surface elements and track the real-time development of stars. It's unclear, though, if this evolution portends the Betelgeuse supernova explosion because of the peculiar phenomena. NASA has cautioned that Betelgeuse is still alive and well despite its extended cosmic existence. NASA predicts that during the next 100,000 years, Betelgeuse will blow up and red supergiants will be dying out quickly. Since the 1st century, it has been the subject of much inquiry. Scientist Serafina Nance and her colleagues recently attempted to estimate the most likely time for a red supergiant star, similar to Betelgeuse, to explode as a supernova. Using Betelgeuse as a model, Nance and his colleagues ran a number of tests to determine the mass of a star. After that, they contrasted their results with field notes. If Betelgeuse isn't going to blow up for another 100,000 years, then why is he shrinking and going out of phase with his regular cycle? After being expelled from its residence in the star cluster Orion OB1, a star cluster in Orion's belt, Betelgeuse looks to be moving at a speed of 30 km/s across the interstellar medium, covering 4 light-years. Shock waves are created by stars in motion. By mid-February 2020, Betelgeuse's brightness has almost quadrupled from 0.5 magnitude to 1.7 magnitude following its fall in October 2019. The star began to shine once again in the last 10 days. But after 5 days, Betelgeuse appears to totally stop darkening, bringing the darkness to an end. It seems that the current lack of visibility does not correspond with the demands of youth, as seen by the lack of noteworthy changes in infrared on February 24, 2020. That same day, another investigation came to the conclusion that dust was primarily to blame for the star's dimming. It appears that the fading will bring about the second dimming event sooner than anticipated. On August 30, 2020, scientists revealed the finding of a second cloud from Betelgeuse along with the star's final significant light decrease. A second research in August 2020 supported the June 2020 suggestion that the dust may originate from cool regions in the photosphere. It is believed that the dust is the result of gas fleeing the star. Dust can be produced by large-scale soil removal, according to a Hubble Space Telescope research from 2022. Millions of km are expended from the star's surface, where the material cools and condenses into faint stardust. When it entered space, the broken photosphere, which weighed roughly several times that of the Moon, cooled and created a cloud that obscured the star from Earth's view. Beginning in late 2019, this decline was evident to observers even after they had seen variations in the star's brightness for several months. More significantly, the 400-day pulse rate of the supergiant has vanished. Astronomers have been monitoring this cycle since over 2 centuries ago by examining variations in Betelgeuse's brightness and velocity. The explosion was evident in his reaction. Now, astronomers have created a hypothesis that could account for this phenomenon. Rebuilding of the star's photosphere and energy supply is happening gradually but steadily. The star's innards vibrates like a cymbal that has been hit, and its orbit is constantly disrupted. There have never been seen large-scale star surface mass ejections previously. We still don't fully comprehend a few things. This new phenomena is immediately observable, and Hubble may be used to view surface details. Watch how stars change over time. When is it going to be? No one truly knows, but perhaps not in our lifetimes. Either tomorrow or in 1,000,000 years, it may occur. Seeing will the Betelgeuse supernova wipe out everything? No, because Betelgeuse exploded so long ago, life on Earth will not be affected or partially ended. According to astronomers, we would need to be 50 light-years distant from a supernova in order for it to pose a threat to humanity. In addition, Betelgeuse has grown by a factor of 10. Rather, the brilliance of the star shining at night will be seen simultaneously by everyone on the planet. Finally, researchers will be able to observe the star during its supernova explosion since Betelgeuse is close by. Don't search for Betelgeuse at night because he is no longer visible. We will not witness anything unless it goes supernova now, in mid-August. Even though Betelgeuse went supernova 529 years ago, its light hasn't been seen yet. The possibility of seeing Betelgeuse's fall and recovery excites scientists. NASA's James Webb Space Telescope is able to watch the insect juice item as it moves across space, while Hubble is still studying the star. Thanks for watching another episode. While you're here, you can watch more space-related video.